section, so let's write continued section 1.2. Okay, so we need to focus that. There we go. Good? Okay, so I spent so much time on such an easy part of fractions. Do you agree with that? There's a really important reason why I did that, and that's because that's the part of fractions that people actually go wrong with, is the simplifying. Multiplying fractions and simplifying. Common denominators, for some reason, is a lot easier, although the topic itself, when you first learned it, is probably harder. So we're going to talk about common denominators. I'm going to do just a couple examples with numbers so that to remind you how to do that. And then we'll jump right into variables. So I'm even going to go as far as saying that there's 3 types. And we're going to do 3 types of common denominators. So this is going to be type 1. And type 1 is if the denominators don't have any factors that they have in common. So we've got a 3 and a 4. They have no factors in common. They're already in there. 4, the only factors of 4 are 2 and 2. And there's not a 2 over here. So what do we do when we have a fraction that we want to add like that? Is that we need to find the common denominator. The lowest common denominator is really important here because you have no calculator. You could do 12, which is the lowest common denominator, 3 times 4. What would be another denominator that you could make these 2 fractions have, but that's not 12? 24. Right? You can multiply the first one by 8 and the second one by 6. And that will give you 24. And that's okay. It's just it's not the lowest, so then you'd have to reduce it. So if you find the lowest one, that's better because you don't have to reduce it. And when we add variables in there, reducing it means factoring. Sometimes not easily factoring, so you always want to go with the lowest. So the lowest here, the lowest common denominator is 12, which is 3 times 4. So we would take our first fraction and multiply that by 4, and our second fraction multiply by 3. We write our new fractions. And once you have a common denominator, you've got 3 pieces out of 12 plus 4 pieces out of 12, which is 7 pieces out of 12. So that's type 1, where you need to change both denominators. That's what type 1, yeah?
So are we supposed to put like each step?
You don't, yeah, and you don't even need each step here because probably you would jump ahead, hopefully. You jump from here to here. Down or sideways, yeah. So down is good to keep the equal signs equal. And I said last class, I don't always write them that way myself. What you have to be really careful of, whichever way you do it, is that the stuff that's in here is actually equal to this. Sometimes people will just write here like 3 plus 4, and then they'll put the answer 7 over 12. Like they'll do a part of it and not the whole thing. As long as everything between your equal signs are equal, then it's okay. Okay? So the second type. So type 1 was that they didn't have any common factors in the denominator already. Type 2 is that they do have common factors in the denominator. So they both have a factor of 3. Right, I can say that 6 is 3 times 2. Now, I'm writing it this way on purpose because when we add variables in, it becomes tricky. But if you can remember that this is what you're actually doing, you're not just jumping to the 6. So 6 is 3 times 2. Do you see they already have a 3 in common? So for them to be equal, the first one needs to have a 2. And if you put the 2 on the bottom, you need to put it on top. And now they've both got a 3 and a 2. Okay? So, and when we add we multiply 4 over 6 plus 5 over 6 is one fraction, 4 plus 5, which is 9 over 6. And what I'm saying here is you could just jump from this to the final answer, right? You don't need to show that step. But now, where do people go wrong? People go wrong with this is that they do this multiply by 2, then they say, oh, that fraction can be reduced, and they reduce it back to the start. Can you see yourself doing that? Be careful of that. All right. I've seen it all. And let's say type 3 is this, where one of them doesn't look like a fraction, although every number is a fraction. It doesn't look like a fraction when it's given. So this is 2 over 1 plus 4 over 3. And now for a common denominator, we would need to multiply this one by 3. 3 times 1 is 3, and then they'll be the same. So 6 over 3 plus 4 over 3 is 10 over 3. Oops, sorry. There we go. Okay, so we're going to jump right into variables and do sort of the same thing. So the variable, oh yeah, question? Oh, thank you. I didn't notice that it actually can, and I would say write your answer in simplest form. So yeah, this one can be simplified. Thank you. I didn't even notice. There we go. And now I'm quickly looking at the other ones, and we're okay with the other ones. Remember, this one is called an improper fraction, but we don't write it as a mixed fraction. Okay. What happens is we're going to take that and multiply by x later. And if you write it as a mixed fraction, then it's hard to multiply by x. You don't know what part to multiply by x, and that won't work very nice. Okay. So here I just put a variable on the top. So the method is exactly the same as the first question we did, which is to multiply the first one by 3 and the second one by 4. Usually the 3 would go in front of the x. And then we can write it as one big fraction, except the last step's not there, is adding them together, because that would be as far as you can add them. So that last step on each of these, write it as one fraction, and when they're just numbers, you can just add it and get the answer. Now you can't. Okay? Type 2, when only one of the fractions needs to be changed. So what would we do here? Common denominator would be 9, so we need to multiply the first one by 3 and leave the second one alone. So 2x times 3. 6x. That's 2 times x times 3. You can multiply them in any order. The 2 and the 3 multiply to give 6. Remember, the 2 is not attached to that x. Now we have a common denominator, 6x minus x. We're subtracting, and they can be subtracted this time because they both have an x. So this would be 5x over 9. 6x minus 1x. Now, we can have the expression be a little bit more complicated. And this question's reminding me that someone pointed out a typo in the textbook, and I will fix that. I just remembered that right now. So someone, and it was with a case like this, so there is a typo. If you said, geez, I read that section and didn't find it, maybe you should go back and look, because there was something that if you were working through the textbook, like I said, like with a paper and pencil and actually trying the questions, instead of just reading them, then hopefully you caught one that yours didn't match mine. And then you looked at mine and said, okay, well, she must be right. But one person pointed it out, and it was a typo. All right, so here we go. This is like type 1, where we need to multiply both. So we're going to multiply the first one by 2. But because there's more than one term in the numerator here on top, we want to make sure that's in a bracket. So we're multiplying the whole fraction by 2, not just part of it. And the same here, we're going to make sure that we put that in a bracket. We're multiplying that whole thing by 3. So this will be 2, and we say 2 on 2, 5x plus 1, over 6. And this is 3 on 2, 2x plus 1, over 6. So it does mean multiply, but we say onto because you actually have to distribute it to everything inside that bracket. It's not just 2 times 5x plus 1. If you read it like that, you're actually saying 2 times 5. If you read it 2 times 5x plus 1, you're reading it as multiplying the 2 times the 5x only, and not the 1. So the way we actually read this is 2 onto 5x plus 1, and that's telling us that the 5x plus 1 is all together. All right. So when we put this all together as one big fraction, it's not as simple as just adding 2 numbers together. We have to work it all out so that they're individual terms, and then we add together what we can. So if we were to work this out, this will be 2 onto 5x plus 1. So we multiply the 2 by everything inside, by both the 5, so 10x, and the 1. And here this is a negative 3. That negative has to apply, because you're subtracting the whole thing, has to apply to both terms. So minus 6x, minus 3 times positive 1 is minus 3. And now we have individual terms that we can add or subtract. So the 10x, and we're going to minus 6x. And then we've got a plus 2 and a minus 3. I'm just rearranging them for you to see it better, but you don't need to do that, of course. This is 4x. Plus 2 minus 3 is minus 1. Whoops, sorry. Let me know if I'm off the page. So 10x minus 6, 4x. And plus 2 minus 3 is minus 1. Does that simplify? No. No, no, no. It does not. Let me show you something that does simplify, okay? Some people say, yes, that does simplify because the 4 and the 6 both have a 2 in them. Yeah, but there's a problem. This 6 is divided by the whole thing, not just the 4. So it also would have to have a 2 in the other term. So let's say simplifying as the instructions. Okay, now look at this one as opposed to here. And this, you can see a 2 in each of the terms, each of the parts. So in order to cancel something out, okay, take a look at what I wrote. Write it down. Take a look at it. I've rewritten the equation, still equal. What did I change? I'm reminding you that this is 2 times x, not a 2x attached. This is actually 2 times x. So I'm reminding you of that. That's on the top. On the bottom, what's it called when I change the 4x minus 2 to this? Factoring. Right. So I factored a common factor. I divided the 2 out of each term. If you divide the 2 here, 4x divided by 2, the 2's cancel and you get a 2x. Here, minus 2 divided by 2 is minus 1. So I get the 2x minus 1. And that's what you're doing when you're factoring. You're pulling it out to the front, but it's actually dividing it out of each term. So this is the same expression. Now this is 2 times that bracket. Do you agree? And so we do have on top and on bottom 2 times something, and that's why we can cancel it. And we would have x over 2x minus 1 as our answer. But nothing else cancels, not this x, because the x had to be in all 3 for an x to cancel. Just like this 2 was in all 3 parts for it to cancel. Okay, so here's an example. Same thing. What's going to cancel? A 5 out of all 3 parts. Here we could say this is 5 on 2. If we divide the 5 out, we're left with an x. We divide the 5 out, we're left with a plus 2. And now that 5 is on top and on bottom multiplied. This would be like times 1 if you want. They cancel. And you don't need to write divide it by 1. 1 on the bottom can be left out, not the other way around though. Questions? Okay, so here I said simplify, then add. Okay, so let's talk about why I'm telling you to simplify first. You should always try to simplify your fractions first before you add. For the same reason I said earlier, is that you have no calculator and you're making things more complicated if you don't simplify them first. When you add variables in, to simplify variable is more than just finding the factors, it's actually factoring. Okay, so this first one does simplify, the second one does not. There's not a common factor, but here this has a common factor of 3. So I could off to the side figure out what that looks like. So I could say, all right, well, a 3 factors out of the bottom, and the 3's will cancel. What would you have left on top? 1. And that's off to the side. I can then come over here and write it in. Okay. Now, why did I do that off to the side? Any ideas? Yeah, the other option is this. All right, I've got 3 over 3x plus 6 plus 5 over x plus 2. I'm going to simplify this first one, so I need to pull out a 3, and then those cancel, and then I need to add this, and now you get your whole question marked wrong. Right. When you're doing just part of it, you still have to write, each line has to be equal, right? So if you do it off to the side and then transfer it back over, we're still equal. This is equal to this, and that's equal to that, and I have everything included. This happens a lot when you have multi-part questions. It could have been much more complicated than just canceling out a 3. Okay, so it wasn't to show my work. If you just jumped from here to here, I would mark that right, as long as the whole line is written there. Okay, so you don't even need to show your work off to the side. I show it because I don't want to lose one person in the class and then be lost and then be lost the rest of the class, because that sometimes math frustrates people if they get lost. So I do like overkill on the steps. You don't need to do as many steps as me. If you can skip right to this from here, that's fine. I do it off to the side because I didn't feel like writing that part. Sometimes you're just working on one part of a question and the rest is like 5 terms, 5 more fractions to write. So you're just working on one fraction, but if you're doing it with equal signs, you have to rewrite all 4 of the other parts. Then you just do one more step, write all 4 of the other parts. Do one more step, write all 4 of the... So if you just did that one part off to the side and then transferred it back in, it's correct. Does that make sense? So yeah, I'd mark that whole thing wrong, because it's very wrong if you were missing that piece. Okay, so in this case, when we simplified, we actually had a common denominator, x plus 2. Nothing else simplifies. So there's not a 2 with each part. And that would be the answer. If you didn't simplify first, what would the common denominator be? You would do 3x plus 6 times x plus 2. You'd multiply this one on top and bottom by 3x plus 6. Multiply this one on top and bottom by x plus 2. You've got tons of x's in there. You then would have a top, like the last question we did over here. You'd have some stuff like this on top. You would have to do that. What's left would then factor, and then it would cancel with the 3 in the end. You'd end up with the same answer, but a whole page of work, because you didn't simplify in the beginning. Okay, so you should always say to yourself, before I add these, can I simplify them? Okay, so this can't be simplified before I start. But now I'm putting, before I wasn't really putting any variables in the denominator in the bottom that I had to find a common denominator for. So I'm adding that in. So now we've got, what would be the common denominator here? 3x. Because on the bottom of one is 3 times x, and the other one is x, so it would need a 3 to be equal. So this is times 3. Then we would do the same thing. Two minus 3 is negative 1 over 3x. Now here's one where people go wrong. What's the common denominator? So I hope that people go wrong, so I always hope for the wrong answer. And I guess that's just for my own ego, so that I know that you actually do go wrong this way. I don't know. It's also to show, I always tell my kids that learning takes place when you get something wrong, not when you get it right. If you struggle with something, you'll learn it better than if you didn't. Okay, you'll also remember it better. So making mistakes, someone in my finance class this morning, my 3rd-year finance course, came up with a question. And she said she spent a half hour on it. This is only the first week of class, and the topics are quite easy, actually, in the first week of class. And she said she spent a half hour on it, and I looked at it, I knew right away. She copied the question wrong. So her answer didn't work, didn't match the answer that I gave them. And she spent a half an hour working on this question, changing the numbers and wondering what formula she's supposed to use. And so I said, that was supposed to be 1%, not a 3%? Oh, no. And I said, it's okay. You will never copy a question wrong again, because you don't want to spend another half hour, right? When she doesn't have a matching answer, what's she going to do? She's going to check her question first before she checks what she did, right? So when you make a mistake, it's okay. It just means you're learning, and you won't do that same mistake. That being said, you actually have to correct your mistakes. So if you got your assignment back and you looked at your mark and you said, oh, great, 18 out of 20, that's really good. But you don't actually look at what you did wrong, you'll do that thing wrong again and again and again because you didn't learn from your mistake, right? So, common denominator here, some people would say x plus 1, but it is not. Let me remind you of a question similar, like this. 4 is 3 plus 1, do you agree? So do you just add 1 over here? No. When it's 4 and 3 and they have nothing in common, and every number only 1 apart have nothing in common, then you multiply the first one by 3 and multiply the second one by 4. And that is not called cross-multiplying. Okay, don't call it that. So here we need to multiply the first one by x plus 1. Make sure it's in a bracket because it has more than one term. And the second one by x. And our common denominator is actually x onto x plus 1. So here we have 1 times x plus 1 minus 5 times x. That's just x plus 1 minus 5x. So here our common terms is an x minus 5x. So 1 minus 5 is minus 4 plus 1. Now I personally like this answer better than what? What do some of you maybe want to do here? That? Okay. And they're both fine. They're both acceptable, and I would not mark either one of them wrong, okay? But remember what I said, factored is simplified. Factored is simplified. Factored is simplified. If you expand, and here you'll notice if something cancels if you've already factored the bottom. The top later, when we go back to fractions, when we're factoring, you'll be able to factor the top and then something will cancel. If you expand the denominator, then you have to refactor it to simplify. So factored is more simplified, but either way is fine. I forget what I did in the textbook. I probably expanded them. That's sort of more standard to see, but I want to tell you that either is acceptable, and actually not factoring it, or not expanding it's a little bit better, because you can check, you can cancel things out if they need to be. Now why does the x not cancel here? It is multiplied on the bottom. To cancel, no, nothing to do with the negative. Right, there's a plus 1 that doesn't have an x in it. Right, the x has to be, because this x on top is not multiplied by the whole top. You can't cancel it unless it's multiplied by the whole thing. This is multiplied by the whole rest of that term, that x on the bottom. But on top, there's a plus 1. It doesn't have an x in it. So you can't cancel that one. Okay, here we go. can any of these be simplified before we start? Both, actually, both, yeah. What are we going to factor out of everything in this one? A 2. So we're going to write that as 2 times 5x, 2 onto x minus 4. Now the 2 is multiplied by 5x, so we can cancel it. The 2 is multiplied. It has to be multiplied by everything. What are we going to be able to cancel out of 15 and 18? 3? 3 times 5 and 3 times 6? Sure. So this will be 5x over x minus 4 and 5 over 6. So making it smaller before you start is usually a good thing to look for. Can I simplify it? Then do your common denominator. Common denominator? You have to multiply the 2, so we would call it 6 on 2, because it's a bracket, x minus 4. So 5x, x minus 4, put that in a bracket, because it has 2 terms, times 6. X minus 4. So 5 times 6. And I'm just going to leave this one like that. I could multiply the 6 through, but again, I'm going to leave it factored. Here, this 5 goes with both. And I guess I'll apologize. Usually I put it as one fraction before I did that, but it does work the same way. Just watch the sign here. That was a plus, so it doesn't change the signs. Okay, what I'm saying is I apologize, because what I usually did was write it as one big fraction and then work that top out. Okay, which either way is fine. This way is better, because if there's a minus sign, sometimes when you do it separate like that, then you forget to apply the minus to both terms on top, so just be careful of that. So 30x and 5x, 35x. Minus 20. So my question is, does anything cancel or simplify? We can factor the top. Do you see that? It does factor. It's really actually not going to help us, because what factors out of these 35 and the 20? 5. So I could write 5 onto 7x minus 4. The minus 4s don't cancel, because they're not multiplied, and that's a 5 and a 6, which of course don't cancel. But you can appreciate that maybe if that did simplify and we pulled out maybe a 2 or something, then we could have canceled it, or a 6, then we could have canceled it. So it's better to leave the bottom factored so that you can check for that kind of thing. Okay, so let's talk about a few strange happenings. What if you subtract a fraction? Let me give an example. What if we did something like this? All right, back to order of operations. I'll let you write it down. And you can ignore me and try it if you want. What do we do first? Yeah, so there's sort of 3 sets of brackets here. Do you see the 3 sets? Let's say this is 1, this is 2, and this one's 3. What do we do first here? Probably this one inside the other one. We could do this at the same level. That would be okay, because we need to figure that out eventually. But to do this second part, we need that number. So we could do this and say this is the common denominator here, 3, right? And at the same time, just rewriting everything else, we could do this. What's 11? These already have a common denominator. So we just need to do 11 minus 9, which is what? 2? 2 over 2? Right? Okay. So here we've got 12 over 3 minus 1 over 3, divided by 2 minus 2 over 2. And you see, I'm sort of working in two places at the same time. I have to rewrite the whole thing anyway, so it's a good, if you can do that, do it. If not, you could solve these two brackets individually off to the side, and then put the two numbers back with the divide. That would be the other thing you could do. What's this equal? 12 minus 1 is 11 over 3. What about 2 minus 2 over 2? Do we need a common denominator? No, because what's 2 over 2? 1. So here we've got 2 minus 1, which is what? 1. So what's 11 over 3 divided by 1? Just 11 over 3. I mean, you could write it out, times 1 over 1. But of course you wouldn't need to do that. Now what if we divide by 0? You saw that on the homework? Did you try the homework yet? Quite a few people have asked me about that one. So what if we, but I didn't teach it yet, but I did answer this time. So what if we end up with something like that? Like, say you end up with a 0 here. You know, it could have started more complicated like this one above. When we worked that out, that worked out to a 1. But what if it had worked out to a 0? Undefined. You can't divide by 0. We talked about that last time. So that's undefined. A number divided by 0 is undefined. That means it has no answer. It is not equal to infinity. That's not right. That's actually very wrong. If you did limits, maybe, in limits something can approach infinity. It's not actually equal infinity, although you put an equal sign. But the word limit means approach. So if you did that, you would have answers that were infinity. But that's only because we're talking about a graph. We're talking about the behavior of the function as x gets larger and larger might approach infinity, or the behavior of something can approach infinity. You can get close, but you can never equal infinity. So if you write equals infinity, then I mark it wrong, because that's not a thing. It's undefined, okay? There are cases, but it's only in limits, where you can actually say something's equal to infinity. What if we had the other way around? What if we worked out our two brackets and we had it this way? Yeah, 0 divided by a number, so this would be 0 times 4 over 3. That's like 0 over 1, which is 0 over 3, which is 0. 0 over a number is okay, that's equal to 0. Okay, 0 on top's okay, you can have nothing. But you can't divide something by 0, because dividing itself is breaking it up into groups, and you can't break something up into 0 groups. That doesn't work. Okay? Okay, I just am double checking. I think we're good. So that's the end of 1.2. So for next class, you're going to read 1.3. Okay, before class, remind yourself of what we're going to talk about.